Basically, we're just going to like re-emphasize what we've been speaking about in a little bit more detail. We'll just start here or whatever. We just simply put in the relationship here between this and this, just to, you know, if people weren't clear on the drawings what actually should happen. Now, whether that joint is there, or there, it doesn't make a difference. This is the most common way of doing it. And, you know, you'll have the next panel there. But that's the relationship, and that's roughly the proportions you would be working on. 20 millimeters here. Louis, what did you say this was? Sorry. How much down here? 30 or 40 or something? 30? Yeah. About 30 millimeters down here of cover on it, okay? Now, okay, in theory, we asked for 20 here. This is only 10. But let's be honest, if you aim for 20, you're guaranteed that someone will at least get 10. Yeah? Aim for 10, you might end up with 5. You're going to be in trouble. Remember what I said about minimum does not equal targets. We already discussed it yesterday. By the way, I'd like to introduce you to John, my helper for today. Okay, we put up the frame. We're on a light gauge, steel gauge system, and I said we would talk about this a little bit more detail here with the problems you may encounter in this type of construction. The bigger issue comes that the guys who put up the steel frame on the inside may not always end up, I can guarantee you, in the right place for you to put your frame in for the size of the panel. Everything works in the opposite direction. The architect has set the panel and where he wants the joints in the panel, which tells you where you need your rails, which tells you where you need your brackets, which should tell you where the stud should be. But let's be honest and let's be realistic, I probably have a better chance of winning the national lottery than I have of getting all that to work on a job site. So, we were lucky enough here, we were able to jig it around so everything worked in nicely. But in reality, what normally happens at this point of view, you've got to have the thinking that, okay, you're pricing up a job, it has a vertical stud, light gauge steel wall in first, and now we have to put our stuff on the outside. What you have to have is some kind of horizontal support in there, okay? Now, whether that's noggins or struts or whatever you call them here between the studs. In the USA, they use a thing, oh, I love the hat, pink. Oh, huh? Matches the colour of my eyes. Huh? Okay. What happens is that you need some kind of horizontal structure in here to pick up the verticals, because the verticals are going to be in a fixed position. And if it falls between two studs, you need something. In the USA, as I was about to say, they use a thing called strapping. So on the outside of the metal gauge, they use a strap of metal across at something like 600 centres that allows them to put their, fix their structure through to this strapping, even if it falls between two studs. More common is using noggins or struts between the studs to pick up the verticals, okay? Alternative to that, if it's not built into the frame, then it becomes a little bit of your responsibility. And what happens there is that normally you end up having a horizontal and a vertical structure here. So you end up having to maybe put something horizontal across first, maybe omegas, top hats, Z's or something that will allow you then to put your verticals. In that scenario, I would not probably go with something like an LT rail and bracket system. I'd probably be playing more in line with top hat sections. So you could run a very simple top hat across at whatever centres, metre, 1.5 metre centres, and then just run vertical top hats on that. Okay? Probably a very cheap and cheerful system to do it, and it gives you total freedom to where you put your verticals. Yeah? Do we understand that? Yeah? So, but here we're on an aluminium system. Important to have these in at the bottom. As we get into bigger cavities and stuff, sometimes you have to double them up. Normally I fix one to the wall. Another idea that, as we spoke about yesterday with Louis, is that you can put a solid piece in first and then have this just on the outside. So you don't have to have this. We just need whatever cavity space is designed. If it's a 50 millimeter cavity, you've got to ventilate the 50 millimeters. If it's 60 millimeters, 60. If it's 30, 30. Okay? So to support the insulation or whatever, you can have a bracket here. What is unique with our system, because we have this gap at the back of the bracket and stuff, There always used to be a problem with the older systems in the sense that you couldn't put a rivet on the outside here to hold this into place. You had to actually fix it in here at the back. Okay? And we came up with ingenious solutions and everything to do that, but this is a much easier and simple system. What I would say is that people would say, oh, but you're fixing this across these. You're fixing them into slots, so there is a little bit of movement in this. Okay? So we have our system up. As we said, fixed brackets are all on the same level across the middle, usually a double-sized bracket. When you're using these, do you use one size bracket or two sizes of bracket?
Two sizes.
Two sizes. Very good practice to use two sizes. As well as supporting the extra weight, you know there's no mistakes can be made where the fixed points and gliding points are going to be now. Okay, when it comes to the brackets, of course, you know, these are very simple brackets. The holes which are being sort of punched here for the fixings for the fixed points and the slots. And whatever happens, guys, I have seen it so often, that instead of putting the fixing here, they put the fixing in one side of it. It's totally getting away from what the reason is you're using the thing for. Okay? And that is a common thing that happens on the job site. Okay. So, basically what we'll do now is we'll go over to the cutting table, so we'll prepare a panel that has to be used and what has to happen, and then we'll fix up. So for face up or face down, as I said previously, that the majority of panels or saws work on a face down system. Hence, if you see here on the table, we kind of use like a sacrificial piece on the tables, either a softer material, something like either a soft board, maybe a rigid insulation or something, even though I don't like using the insulations because it does affect the sharpness of the saw blade. Something like a piece of chipboard like we have here. Okay, normally when we set the saw blade, it would normally be set to approximately around 5 millimeters below the level of the panel. Just enough that it exhausts all the dust and all the crap out of the system. Okay? Am I to do one, or does somebody want to do one first? I'll do one.
I'm used to clamp
You clamp this down, yeah?
on a 3 meter panel.
On the longer panels it is better. Right? By the way, I'm going to let you know now before you say anything and get very smart. I don't use first class materials when I'm doing training. Why should I waste good material just cutting it up and throwing it out? So basically you're going to see materials here with scratches and marks and bows and twists and all the rest of it. I use stuff that's left over that we can't sell, because when I'm finished today it gets all dumped in the dumpster anyway, right? So that cuts out all the smart comments on, oh look at the bend in the panel, oh look it's all scratched on the surface, okay? Basically, as you can see, this high-tech security guard here, that's not working properly. This is just for your protection, by the way, to stop the dust. But normally, the saw blade, which we have one here, makes it easier. Where's the saw blade gone? Oh, it's over here, sorry. These are the fine saw blades, diamond tipped, minimum teeth. If you want to pass it around there, it's quite a heavy blade as well. Makes it very stable. So a lot of the time on blades of this diameter, you're usually down on a very narrow blade that's a little bit thicker and stuff. As I said, you can get local companies to resharpen these if you want at a minimal cost as well, give you another few thousand meters of cutting out of them. But basically, yeah. Oh yeah. Yeah, no, safety first, huh? Okay, usually the vacuum system works with the saws. It usually kicks in with the saws. That would normally be the speed that you would be normally pushing the blade at. It's just a bit dusty, that's all. Okay? You can see, like, you know, it gives a nice cut. If you're using other blades and stuff, you will be pushing it a lot slower and the blade is moving a lot slower. In fact, the blade would be running something like that speed on using a standard blade. Okay? For us, we're running at an average of that speed. Okay? Because the blade is moving faster, you can actually push the saw faster. The blade will actually cut the material. Not too fast, as you will get some resistance to the saw and you might experience a risk of a small bit of a kick or whatever. Okay? Whatever you can do to make it easier and faster for yourselves, you know, do it. You know, for me, this table, it's here, I know. It's here for other reasons as well. We're utilizing it. We put extra bits of timber on top here. But what happens here is, for me, this is a little bit too high still. It's okay for messing at demonstration purposes like this and doing it like this. Yeah? Okay? Now, we can cut face up if you want, and we can get a good cut most of the time. But cutting face down with these type of saws, you're more or less guaranteed to get a good cut all the time. Okay? You have to be a little bit more careful face up. There's also a risk of maybe scratching. You do have to be careful on the surface. That's why some people use these little pads or little bits of carpet. The surface at the big panel then is easy to swivel around and move around on it without risk of damage. If there is bits of stones or grit here, there is a risk that you scratch the surface, of course. Now, the secret when you're cutting as well, when you're using these saws, is that you let the saw get up to full speed before you start pushing it through the material. Okay, so it has to get, the blade has to be up before you drop it and let it go. Okay. Next issue, we have the panel is cut, and if you're using Luco, this is the material here. Right, I'm going to give you fair warning. I'm not going to do it first. I want some sacrificial lambs. I want some volunteers up first. Okay, I'll give you the process. There's two types available. This type and this type. As applicators, what I suggest is you chuck this one and use this one. Okay? Right, some of the questions we get, it's not good for you. Okay, some of the questions we get with this, oh, can I leave it open? No. What happens is it starts forming a crust, it reacts with oxygen in the air and stuff. Okay, only use the amount you're going to be using for a certain period of time. Okay, one fair warning with this Luco. If you get it on the surface of the panel and it's not removed straight away, you run the risk of having a stain on the panel that you won't see only when the light hits it. Okay? And don't come running back, it can't be cleaned off. So these are the applicators. I don't need this for this, so chuck away. This is the applicators. One thing to be careful of is when guys are doing it is moving the brush over the surface of the materials. Yeah? Dabbing here, running across, risks of drips. Here it's not critical because we're on small pieces. When you're on big pieces, it's a much bigger issue. Okay? So, who likes to try first? Remember what I said? If it ends up on the surface.
Can I ask a question?
Yeah.
Don't we sand down? I haven't seen it be did.
Oh yeah, we done it here earlier on. We done the two here.
Okay, so we sand down and then we look.
Yeah.
Now that was a look to the cue.
Well, while we're at it, why don't we just do all the sides? Okay, now we're sanded and cleaned and ready for Luco. Well done, Brenda. So we have our panel ready for the Luco application. Who wants to have first go on it? Huh? I wasn't, okay. Volunteer. Right? Now. Just one time. Now, what was wrong there? Look what's down along the top of the material. Can you see it from there? Yes. You see this glistening line? Yeah, now you have a risk. Oh, I have to clean that off. Right? So you clean it off. Risk is you take it off the edge as well. Yeah? Anybody else want to try? See, can they do better? Or does somebody want to know what the trick is? Yes. Okay. If we go from this to this, even if you look here, you can see how much is bubbling up on the edges. Yeah? But none gets on top. And the reason for that is it's much easier to control. You were right. Yeah, because it was like this. When you go like this and squeeze on, it's going in on top. If you angle back, you can control the edge and the Luco straight away, and you make sure it's done. And it's much faster to do it that way. And to be honest with you, after a few panels, the guys that will be doing it will be flying along.
How long does it take to dry?
By the time that panel has been just moved and ready for drilling, it's ready to go. Yeah? Now you can drill it before you Luco it, which is, of course, is another way. But basically, once you've Lucoed, the thing about Luco, and it gives you the huge advantage, is that once it's like this, that panel now can be moved and be ready to be put up. So by the time you've transported from here to there, the stuff is dry. There's other sealants you can use and other ones you can use, but you've got to let them for 24 hours to dry. This can be used straight away. Okay? Don't generally do the rivet holes. The risk of getting efflorescence around the rivet holes in the staining is a lot smaller. Okay, in an ideal world, if you wanted to be 120% risk-free, you do the rivet holes. What do you clean your ears with if you clean your ears? Earbuds. Do you want to go in earbud 24 fixing holes in every single panel? Fine. You're guaranteed no risk. However, what you've got to bear in mind is that the edge is always exposed. The rivet hole is generally protected initially with the rivet or the screw. Okay, I'm not saying it doesn't happen, but it's a much smaller risk of it happening, and because it's so much smaller, it dries out a lot quicker. Yeah? Where on the edges, particularly the top edge, the water can be resting on the top edge, and it takes a good bit of while for that to dry back out and stuff like that. Okay? So if you want to do them, you can. I don't insist on them being done. Okay? They can be done if you want. I've seen them being done on some job sites, and the majority of them don't do the holes because it's protected by the heads of the rivet and everything. Yeah?
What do you wash this brush? Or
just warm water.
Warm water, and
yeah.
you can reuse it.
And reuse it and reuse it. But you cannot reuse. You should not pour this back into here. This now has dust in it. Okay? You cannot pour it back into here. Also, be very careful. This does have a shelf life. Okay? Usually 6 months from when it's opened. Okay? And you can see roughly if it's going off is it'll form a solid crust on the bottom here. Okay? But for me, that much, this used to be, this was one that was supplied. Our competitors use this one. Believe it or not, they buy it from us in this container. But it's just not as easy to control as this one. Yeah? And by doing it just with that little angle, that little trick of using the angle, speeds up the process, makes it much faster, less cleaning, less risk of staining the surfaces of the panels. Okay? Happy enough? Important part of the kit, coloured pencils. Not so critical on this particular colour panel, but if you're using the darker panels, of course it is. If you come up and you see here, you see what happens with the drill bit here. You can see the way what happens is it actually cuts it into little slivers. Very little dust being formed. Yeah? Ah. It's okay. Yeah, I'll need that over there. You can see, you know, it's a lot less likely to slip as well. Usually we drill not over the edge like this. What can happen is if you look here, you can see that the chuck ends up giving a mark, and on some of the drillers the rivet won't cover that. So you'll end up with a ring around on the outside of it. If you're cutting on something like a sacrificial table or whatever, as soon as you see the different colour coming through, you know you've gone through the board. Also, what happens a lot of the time as well, not so bad here, but here you can see in a bad situation you actually blow out a lot of the panel out the back of the board. If that is consistent on the pan, you're getting much more pull-out resistance from the rivet because the board is much thinner. Okay? Anybody want to try? It's there to do. There's a standard masonry one. I'll tell you what, here, you use that one and I use this one. Right? Oh, you're going hammer action?
It's the only way it'll work.
Huh?
But they won't be effective.
2, 3, go!
All right. To be fair, it's not this was only new yesterday and we had a few drillers on it and we were playing with it. Yeah? It also drilled a couple of holes in the wall there.
But also this way, your tip's going to heat up excessively.
Exactly. You keep going at that, that's going to get red. Yeah? But even you see the speed, like guys, look. You can buy cheaper drill bits, you can use them. I don't care, I don't give a monkeys, right? The stuff that I'm demonstrating here today will make your life quicker and faster. You could see there, I started after he started drilling with that drill bit. And I was still finished before. You'll probably have 3 or 4 holes drilled by the time you have one drilled. Okay.
But also
Does one of the ladies like to use the other drill?
your punch through at the
Huh?
back is also going to be much worse.
What?
Punching through at the back.
With which one? This one or this one?
No, with that. This effect would be even more severe, that you have there. With that. Once you go through.
Oh yeah, once you pop through, yeah.
Because with this, you don't need to apply weight.
Yeah, yeah. Oh yeah, with that one you don't have to apply any weight. It'll cut it itself. Yeah. You get a small bit of breakout at the bottom, but it's very small. It's tiny compared to normal, huh? Yeah, but that's for fibre cement, not for ceramics. That's fibre cement, not ceramics. So by what I'm saying here and what I kind of want to re-emphasize to you guys is, look, you're professional guys. You're going to be doing hopefully a lot more of this in the future. Just get the right accessories to do it. It'll make it much faster, easier, and a safer application for you guys. Okay? Drill face up, cut face down. Why do we drill face up? Because we don't bust through the surface. Yeah. No, here, look. Watch. And you use the right cloth as well to clean. Yeah? What we have is the centralizing tool, right? And what the centralizing tool does is will centralize the rivet hole in the hole of the panel. What happens is, as it drills, this pops through with another driller, okay? Instead of having to rebuy these the whole time, once the drill bit is worn out and stuff, you can just buy the drillers, simply undo the Allen screw, pop it in, tighten it up, and you're ready to go again. Now, what I will say to you is if you're drilling galvanized steel the whole time, buy a pack of these. It's a harder steel to drill, the drill bits will wear out quicker. Nothing to do with the drill bits, unless you want to start paying for highly expensive ones, it's more to do with what you're drilling. Drilling aluminium, it will last a lot longer. Okay, so just bear that in mind. In the tool kits of the guys, you buy these in packs of 4 or 5, just to make sure they have a pack next to them. Okay, what we've got here now is this, we're just imagining this is the framing system. There's a panel already up there at the top that goes all the way up. Okay, what's the first thing that we need to do?
Measure where your panel is doing.
Measure it up? Oh, put John up. Oh yeah, my mate John, yeah. He's just back from lunch. No, but even before, okay, I could put John up now if you wish, yeah.
First measure weight.
First?
Measure your distance plus the tip.
Exactly. First measure the distance.
You also use one of those.
Yeah.
Much better than that.
All right, roughly 500. Now, of course, on a job site, you wouldn't go along measuring them all. If you have laser levels and stuff like that, you'll ping your lines or you'll use chalk lines over long distances, things like that, yeah? And by the way, these aren't the proper trousers for these yokes. We normally have a slot for that to sit into. So, of course, now, John is the next man up. So normally we would just... So what am I supposed to have measured down to here? 510. Roughly 510. What do I think I have done? No, I've done it correctly. It is 510. Now, go and have a tea break. Double check. Now, if you have a long rail, that's a purpose-built one. You can get these ones like I showed you on my one that I have, where this is already fixed. And you have to do it. Perfect. Okay, yeah, it is right. So, straight away now you can see panels up. Now, what's the next stage? What all goes on before the panel goes on? These are, see what happens when it starts unfrailing and getting stuck and all the other bits and pieces? Yeah, exactly, when you've got gloves on you then, but you don't need the gloves because it's not harmful to you. So normally if you want to, sometimes what guys do is they would pre-cut them for whatever the panels are. Yeah? Now if you imagine you're on a scaffolding and that falls down the scaffolding, it can be a real pain to get the thing done. But for this one, and don't worry, even if it is a bit long or whatever, it doesn't really make a difference. It's easy, comes off. If you're using the baffles, you would put this on before you start using John. Just run it all the way down and don't worry about having to put in the small pieces. All right? Normally, we run it on this side of the joint. I'm just going to leave it there to show you what it looks like in the joint. Okay?
Why do you put it there, not closer to the edge of that?
You mean?
Yeah, but why don't you put it closer to the edge of
You mean put it here? Yeah, okay, I'll put this one here then. Yeah. Doesn't really make much of a difference, to be honest with you. To be honest with you, you're right. I do find this is faster and easier because what you do is you can use your finger and the edge of that as the guideline to make sure it goes down straighter, faster.
And there's no chance
Yeah, if it's too close to the panel, or you leave it down from the panel like this here. Yeah, and then you've got to clean it out of the joint if the joint is open, or you do something like that and you break it off early, yeah? I'm just going to leave it like this, and these things are something that happens. You know, the thing rips and breaks off very easily. If you want to try it, you can squeeze it down and the thing will just expand back up to itself size. Now if you imagine that was a large panel, 3 meters by 1200, that is the panel now up, and one guy can just hold it in place. Yeah? There's no strain, there's no stress, there's no risk of anything moving. How does my joint look? Well, it doesn't look too bad. Do you think it's up or down a bit? It's okay? Huh? Good to go? Next job. What do we do next? Centralizing where? And where's the fixed points? There is no 7 and 8 on this one. Oh, there is. Here's 7 and there's 8. Yeah? Yeah? Yeah, I am in line. Yeah. No, I looked it and I checked it. But you're right. You can check down, make sure everything is nice and straight. Yeah? This is where it gets easy. Even when you lift it up and you put it in place and it is off. You know? Just get the angle. No, yeah, that one. You just push it and hold it in place. Yeah? No strain, there's no pressure. Speed is... Okay, I'm just going to lock this in place first to save Luwick. So red on green. We'll show you what they look like in a minute. We'll do them in a minute. By the way, this is the gazeba, Ackerbird, right? For professional guys, very good, long wearing, batteries last a long time.
So that one has been tested, it will last.
Huh? This is a brand new one.
Yeah, but I mean...
Yeah, no, these are the market leaders. They were bought out by SFS about 2 years ago. We all know who SFS are? Yeah, no, they're large, they're a bit like Fisher's competitors, okay? But these ones would be the market leader in it, and that's why they're the most expensive. They have the longest lasting batteries and the longest okay, you can buy cheaper ones. Excuse me, Luwick, but I did buy a cheap French one, just for training purposes that I do bring around with me from time to time. But as a professional using it, you know, I know it won't last as long as these ones will last, okay? You think I'm selling these now? See me after. I have a few in the back of the car, okay? Just be wary of them. This is the nozzle here on the front that suits the size of the rivet. You all know how the rivet guns work, right? And the rivet has to do with the size of the mandrel that's inside in it here, okay? So for different ones, it's usually in here in the side. You have the different sizes for the different size rivets, okay? Now, but these are usually very good. And what happens then in the end, it collects all the waste in the little cup at the back for you. So you don't have to clean up the site after yourselves. Okay, so now that panel is in place. Does somebody want to drill the next one? Do you know? Whoa, which one would we normally do second?
The other fixing point.
Yeah, where's the next fixing point?
Het moet op dezelfde dingen.
Not on the same rail.
Not there.
That's a fixed point?
Yes.
Where's the next one? Right? Okay, forget what I said. If this is number 8,
Oh, no, yeah.
yeah, this is 7, and this is a number 9.
Okay.
Yeah. Now, she was absolutely probably one of all of you, she knew where they were to go when it was up on the screen. But there's an example when you're in a position of putting it on, how easy it can be to make a mistake. Right? However, if you did have to drill that out, because it's the same size hole and stuff, As long as you didn't put the red rivet in, who cares? Yeah?
I just wanted to show you.
Yeah, she was just testing you guys to make sure you knew what you were looking at. Very good.
Thanks.
Yeah.
I actually just want to test this piece.
Press it again. Put it back on, press it again, and it'll take it away. If it doesn't go the first time, it'll go the second time.
I just wanted to see that you don't have to like press
No, no, no.
it in.
Let the machine do the work. Okay? Well, yeah, you don't damage the rivet. Yeah.
There's no
Right.
more.
I'll drill another one now. Here.
Thanks, that drill.
This one. Go ahead. Slip it off. Didn't take it away. If you put too much pressure, you might get a little black mark in the center of the rivet. Okay? So guys, you can see how quick that can be when you're using it. Like how much strain and pressure did we have like holding up? And you imagine that's the same process for a large panel. Now, we don't have a bit of mesh profile, but I'm just going to show you something here, like I said earlier on. Okay. If you imagine this is a blank horizontal joint profile that you would normally then slide in here. Yeah? Now, to stop that moving sideways like this, which can happen if it's not done, normally all we would do is just give it a quick nick, and you can already see that with the quick nick, it bends it back for you. Yeah? Even with the black plastic ones, even though you should be buying my aluminium ones. And then that just slides up in there. And that now will prevent that from sliding out. Very, a lot more important at an external corner. We have seen instances where them things over time have actually moved out from the corner and stuck out of the building, yeah. But if the emphasis of this part of the training here is just to show you that if you use the correct accessories and get it right in your mind how the procedure should go, it should speed up the fact of the work that you're doing. And we're here to try and help you to do that, to make it sure it's a good job. You get one hit, you get it done, you get off the job site, everybody is happy. Of course, we're always going to have geniuses who will come up with new solutions and new ways of doing it. That's fine. Do that provided you maintain the simple principles that we've talked about here today. Yeah?